Today, we're going to be looking at 3 different approaches to solve the two-sum problem in Java. We'll go through the code for each solution and explain how they work in detail. Now, before we get into the video, if you guys want to see more videos like this, drop a like down below. It helps us out tremendously with the YouTube algorithm, and with that out of the way, let's hop right into it. So the first approach we're going to look at is the brute force approach. Let's take a look at the code. In this brute force solution, we iterate over the array twice, comparing each pair of elements to the target value. Let's break it down. So first, the class is defined with solution as solution with a method TwoSum that takes in an array of integers and nums as a target value. Inside the method, we store the length of the array in the variable n. We start a nested loop where the outer loop iterates from the first element to the second last element using the variable I as the index. The inner loop starts from I plus 1 and goes until the last element of the array using the variable j as the index. This ensures that we compare each pair of elements only once without repetition. In each iteration, we check if the sum of nums I and nums j is equal to the target value. If it is, we found our solution. We create and return a new array containing the indices I and j. If no solution is found after exhausting all of the possible combinations, we return an empty array to indicate that no valid pair exists. This brute force solution works, but has a time complexity of O times n to the n squared, which means that the execution time grows quadratically with the size of the input array. Let's move on to a more optimized approach. Our second solution involves using a hash map to improve the time complexity. Let's take a look at the code. In this solution, we utilize a hash map to store the numbers as keys and their indices as key values. Let's understand the code in detail. We import the necessary classes from java.util and include the map and hash map. Similar to the previous solution, we define the solution class as the TwoSum method that takes in the array nums and the target value. We create a map called nummap using the hash map implementation to store the numbers and their indices. We calculate the length of the input array and store it in the variable n. The first loop iterates over the elements of nums. For each element, we use the put method of the nummap to associate the current number with its index. This step effectively builds the hash map, allowing us to retrieve the index of a number in constant time. Next, we start another loop to find the complement of each number. The complement is calculated as target minus nums I, where I represents the current index. Inside this loop, we check if the complement exists in the hash map using the contains key method. Additionally, we ensure that the complement's index is not the same as the current index to avoid using the same element twice. If both conditions are satisfied, we found our solution. We return a new array containing the current index I and the complement's index nummap.getComplement. Finally, if no solution is found, we return an empty array to indicate the absence of a valid pair. This optimized solution has a time complexity of O times n since both the hash map construction and the lookup operations have constant time complexity. Now let's move on to our final solution, which is a slight improvement over the last one. Our third solution still utilizes a hash map, but with a small modification. Let's take a look at the code. This solution combines the steps of building the hash map and finding the complement into a single loop. Let's examine the code more closely. We import the necessary classes from java.util, including the map and the hash map. As before, we define the solution class, and the TwoSum method takes in the array nums and the target value. We create a map called nummap using the hash map implementation to store the numbers and their indices. We calculate the length of the input array and store it in the variable n. The loop iterates over each element of nums. For each element, we calculate its complement using target minus nums I and store it in the variable complement. Inside the loop, we check if the complement exists in the hash map using the contains key method. If it does, we found our solution. We return a new array containing the complement's index, nummap.getComplement, and the current index I. If the complement is not found, we add the current number and its index to the hash map for future lookups. Finally, if no solution is found after processing all elements, we return an empty array to indicate the absence of a valid pair. This solution maintains the time complexity of O times n while slightly reducing the code complexity. It combines the steps of constructing the hash map and finding the complement into a single loop. If you guys enjoyed or found this video helpful, drop a like down below, subscribe for more, drop a comment if you have any questions, and we'll catch you in the next one.